So yeah, a bit of a snapshot of some of our agronomy trials. So a bit of an outline. I wanted to talk about 4 things in particular. First was our plant growth regulator, or PGR work. Some of the effects of delayed harvest, or the cost of delayed harvest in wheat and barley, some end management in barley, and then some of our results from our wheat and barley time of sowing work down at Tamworth. So in terms of PGR history, our group's had a reasonable history from about 2008 through to 2012, looking at a range of plant growth regulators. But our main objective since about 2010 has really been looking at getting Commander barley to stand up. So it's been focused on lodging management in barley. We've used a range of products, but mainly Cyclocel Modus and a Cyclocel Modus mix. They're our 3 main ones that we've used, and always apply these. So Modus has always gone on at 200 mils to the hectare, Cyclocel at 1 litre, and yeah, they've always gone on a 100 litre water rate at around growth stage 31, or that stem elongation. So it's always been the same for all our trials. So instead of presenting a heap of graphs and that from each one of those trials, I've tried to summarise this into one table. So 2009 was the only wheat year. Since then it's all been barley, and we've got the number of trials. So in 2010 it was 2, 4 and 3. So firstly, looking at lodging. So lodging, we just scored from 0 to 9 as a severity. So that's sort of not just the amount of the plot that's affected, but yeah, the degree in which it's laying over. So 0 is standing up perfectly, and 9 is flat on the ground. So these are the PGR treatments, and this is relative to the control treatment where no PGR was applied. So this, we can see here that in most cases we've managed to reduce lodging severity. So in a couple of these cases we reduced it by up to half, or we're talking 4.8, so that's taking it virtually from flat on the ground in an irrigation system to standing up or being able to harvest it here, particularly in these 2 cases here. Cyclocel generally has been, by itself, has generally been less effective at reducing lodging. There's been some reduction in lodging, but it's definitely not to the same degree as Modus and Cyclocel. And that's mainly because when you combine the 2 products, they actually block gibberellic acid production or growth hormone in 2 spots rather than just 1. So, in terms of plant height, we've all similar to the lodging. The Cyclocel Modus mix is the most effective at reducing plant height, and we've pretty marked. So we've gone from sort of no effect on plant height up to 34 centimetres in plant height, and that was in a trial last year at Moree. So big range in effect on plant height, but generally we're sort of around this sort of 5 to 15 centimetre mark in terms of reduction in height. Again, Cyclocel had slightly mixed results, so sort of sometimes these not necessarily significant increases in plant height, but we're not getting the same consistency as we get with the Cyclocel Modus mix. In terms of yield, this is probably the most variable. So we're getting reasonably consistent or consistent messages through seasons and across sites with these ones here. In terms of yield, we're getting big variations. So in some, we're getting some sort of yield reduction. So in 2012 trial at Moree, we got up to nearly a 0.6 tonne to the hectare yield reduction from the application of Cyclocel Modus mix. But in the same year at Breezer under irrigation, we got a 1.2 tonne to the yield advantage over the control. So we're getting a lot more variability here, an effect on yield again with this Cyclocel Modus mix, but the Cyclocel by itself not changing yield as much. But we have seen some yield benefits from these PGRs, but we haven't really got our handle on what the mechanism or been able to explain that yet. So just key messages out of that. So we've seen consistent reductions in lodging severity, and the Cyclocel Modus mix is most effective. Similar with plant height. And yield, that's where we're getting this inconsistency in some results. So sometimes we're getting yield advantage, sometimes we're getting yield penalty, so which makes it difficult in terms of determining economic benefit. Moving on to delayed harvest. So coming out of the 2011 or 2010-11 season, really wet harvest, and we're looking, well, what's some of the penalty or what's the cost of that delayed harvest or weather conditions? And so 2011 we had a barley trial in, looking across 14 varieties, looking at that cost. And in 2012 we put same trial in for barley, but we also included a wheat trial. So in terms of delayed harvest, we took off, we had 4 harvest dates. The first one was targeted at trying to get it off, optimum conditions, so very little rain on it, and moisture's around sort of that 11 to 12%. So we've taken it off. 2011, that was in sort of, well, they're both in this early November. And then we were timing our other harvest dates to follow a rainfall event or some sort of significant weather event. So 2011 provided a pretty good season for it. So between harvest 1 and 2 we had 34 millimetres, and then 109 millimetres between 2 and 3, and then a further 72 between 3 and 4. So from harvest 1 to 4 we had a 28-day delay, and or just over 200 millimetres of rainfall in that situation. So not quite as much, or the rainfall events weren't quite as large in 2012, but again we're still getting some reasonable rainfall events there. So in terms of yield loss, so this is comparing the two extremes, so harvest 1, so optimum conditions, through to harvest 4. So this is the yield loss between those, and we got a much larger spread in varieties than I was expecting, and probably larger yield losses. So we had up to 76% difference between varieties, and we're sort of ranging from just around that 0.5 tonne to the hectare yield loss up to just over 2 tonne to the hectare.
Harvest 1 to harvest 2, is it?
Harvest 1 to 4.
That's okay. That's the difference between the first and the very last.
Yep. So this is the extreme. But yeah, we got this large separation out between varieties. I guess the main, so this Hindmarsh, Gardner, Shepherd, Commander, all around, just over that tonne to the hectare yield loss. So this is in 2011. If we look at some of the grain quality out of that, we weren't picking up big differences, but we can see there's an increase in grain protein here through the harvest dates, and that's starting to indicate that starches have been remobilised or mobilised in the grain, and it's starting to germinate type thing. So we did see some sprouting by harvest 4 and a little bit in harvest 3, and we can see that our grain weight had started to drop off. So again in 2012 we got not quite as extreme weather events, but we still got this large separation, so we're up to nearly 1.6 tonne yield loss in the worst, and down to 0.2 of a tonne in the best there for barley. And wheat was similar. Yield losses weren't quite as large, but again still spreading from less than that 0.2 tonne to the hectare up to 1.2 tonne to the hectare. So we've got a really big spread there in our varieties. However, if we just look at those qualities, they didn't seem to be enough to explain those type of yield differences. So if we look at other things like lodging, so this is in the 2012 trial. So again on that same scale that I spoke about with the lodging management, 0 to 9, 9 being flat on the ground. So we had a couple of these, so Fathom, Commander and Skipper were nearly flat on the ground in these trials by the time we got to harvest 4. So really driving the lodging, even in some of these more, lodging tolerant or varieties, ones that don't lodge, so Oxford and Fairview in particular, low lodging varieties, even they started to lodge when we delayed that harvest by that long. In the wheat, we even got some lodging in the wheat. 0548 or the LPB line there, very little lodging. But it's a much longer or very long season variety, and it coped with it better. Very short in stature, but yeah, getting up here around 6, not quite as extreme as the barley. And the other thing we've seen in the wheat was some differences in shattering. So again, this is 9 being the worst in the trial. So this is, and 0 0 being no shattering. So we didn't get any shattering in Jandaroy, and in Bounty, we got pretty significant losses in terms of shattering there. So we think that the interaction with lodging and these type of things, head loss in barley and that, is also driving those big differences between varieties. So moving on to some of the end management. So we had a range of trials throughout the region. Two that aren't included in there is Moree and Bithromere. They're the ones I'll talk about today. But we had in the Moree Bithromere trials, we had 4 N rates. So we had 0, 40, 80 and 120 units of N applied at sowing. And then we had 2 split treatments with half, or delayed treatments, half applied at sowing and then another half at stem elongation, or all at stem elongation. So at the Moree site, we can see here that Commander was probably most yield responsive to that N application, and we had yield increases up to about that 80 units of N applied at sowing. This delayed or split N application achieved similar yields to the 80 up front. However, this treatment's particularly useful in something like Commander because it really reduces that, delaying some of that N reduces that lodging risk in Commander. In terms of protein response, so this shaded area is the target range for malting barley, and we can see at those where no N was applied, we weren't actually hitting the target range, and that's become increasingly an increasing issue with barley, where actually it's typically, we've got too much, or used to have too much protein in our barley, and some of the deliveries around Moree last year had Commander less than 8% protein being delivered. So shifting into this range. The other thing to note there, Commander having the lowest protein achievement there compared to Bass. So Bass and Navigator are 2 new malt varieties on the market, but Bass is much more protein responsive compared to Commander. So, there's a 2% protein difference there in that trial. So again, at Bithromere, similar type thing, just showing there. So Commander out there in front in terms of its yield again, but again we see this protein separation here between the varieties. So Commander down the bottom there, and Bass up the top there. So we're still getting that separation across all our sites. So moving on to some of our time of sowing trials. So these are all at Tamworth. So the wheat time of sowing, we had 3 times of sowing, 26th of April, 20th of May, 20th of June, across 21 varieties. I'll just present a subset of those varieties today. But we got this pattern. So even from that 26th of April sowing, that was our maximum yield, and we just got a decline as we shifted. So this is flowering date versus grain yield, and we just got this decline. So even this one out here, so it's long reach dart, flowering in the end of August, is still not getting knocked, or not getting that large yield penalty for flowering that early there. But we're definitely getting the yield penalty for shifting late into October in terms of flowering in the heat. We went from nearly 5.8 tonne to the hectare down to about 3.6 tonne to the hectare between the sowing times. So just point out a couple of key ones. Interestingly, Longreach Spitfire actually performed best from our early time of sowing. So Longreach Spitfire is a quick variety, so we're sort of expecting it to perform better at these, or main to late planting, but performing well in early plant. Caproy also performed well from there. Gregory came good with the main season, so that's its really target range there. But even on that late plant, was able to maintain yield despite being a main season variety with that late planting into June. Suntop was a good performer across all. It was probably our most consistent performer across all sowing times. And Dart, the quick variety, performed well there. In terms of flowering dates, so this is days from sowing to anthesis, and so from that first time of sowing, we're flowering on the 16th, on average, flowering on the 16th of September, 30th of September, and the 16th of October for the 3 sowing times. Suntop there is similar or just slightly quicker than Gregory. Dart was the interesting one, so it didn't actually change its flowering dates or time taken to flowering between these two sowing times. So this looks like about the maximum time it's going to take, that 125 days. So interestingly, we thought, well, this thing's flowered nearly 20 days quicker than the average. I think, well, this thing's going to be ready to harvest. So it was flowering similar to our barleys, but in fact, in terms of harvest, it was similar, or reaching maturity, it was similar to Spitfire. So it had a little bit extra time there from that early time of sowing for grain fill. And this new line coming through, 0548, very long season variety, but it's interesting that in this trial it behaves similar to Gregory. So I would say that in 2012, Gregory was very slow. We noticed that. In terms of barley time of sowing, so same planting dates across 18 varieties. However, in the barley, we didn't get that straight decline. We were getting some penalty from this early flowering. We had a lot more varieties flowering right at the end of August into the first week of September, and we were getting some yield penalty there. So the optimum time was that 20th of May planting, and a real penalty for shifting late with the barley last year. So just pointing out a couple of performers. This was made a little bit more sense. So Fairview and Oxford, longer season varieties performing well from that early plant. However, IGB 1101, which is a quick variety, is very similar to Hindmarsh, actually still performed well early plant. So again, similar to the Spitfire thing in the wheat. From that main season plant, some of these quicker varieties, Hindmarsh and Fathom, came through and performed well. But the long season, so Navigator very long season variety, performed well from that main plant too. Fathom is a quick feed variety, and it's performed well at that last time of sowing, along with Grange and IGB 1101. So Grange was probably one of the more consistent performers across the three planting dates, so showing that flexibility. In terms of flowering date, just highlighting, so IGB 1101's that quick variety, similar to Hindmarsh, or virtually the same. Interestingly, Navigator was actually, so it's a very long season variety, but it was behaving similar to Urambi, which is a true winter type, or got a vernalisation requirement there. Okay, so just some take-home messages. So with our PGR work, we're getting some inconsistency with our yield response in terms of to PGR application. However, we're always, or generally always, reducing lodging severity and plant height across all our trials and sites. In terms of the delayed harvest, we're getting large differences in yield losses between varieties for both wheat and barley in 2012, and that work is going to continue, so we can try and get get an indication of targeting certain varieties to get them off quicker, but trying to explain a bit more of that yield loss. And there's significant differences, particularly with some of the new varieties or barley malting varieties, so Bass in particular coming out in their terms of their protein and yield responses. So Bass is really much higher protein response compared to Commander, and that's sort of going to have to be careful putting that into sort of high residual end paddocks in particular, whereas Commander's at the opposite end. So, and in terms of our time of sowing, our maturity date wasn't always matching up with what we're expecting. So we were, some of those quick varieties performing well early.